Hi, ladies and gentlemen. I hope everyone is doing well today. Today, we're going to take a look at Intro to Moles. I want to start off by saying that I'm sorry about the poor quality of the video. When I went home this weekend to spend some time with my family, I forgot my document cam, so I'm using my mom's webcam at the moment. But bear with me, you should have this in front of you, so you can just read. So right up top, I start off by highlighting that a mole is simply a quantity of atoms, just like a dozen is a quantity of eggs. If you have 2 dozen eggs, you know that's 24. If you have multiple moles, you know how many molecules or atoms you have. Again, we will get into that number later. So to start off with questions 1 through 5, you're going to be referencing these boxes here that have dots in it. So what you need to know to answer these questions is that on the left side, the box has 6 dots in it. 6 dots will equal 1 mole of neon. If you have 1 mole of neon, it's about 20 grams. On the other side, you only have 3 dots. Everything is cut in half. So you have 3 dots. I accidentally wrote 1 mole of neon, but it should say 0.5 moles of neon, and that equals 10 grams. Knowing that information will help you answer questions 1 through 5. Alright, so next we come to some information. What is a mole? So it tells us that 6.02 times 10 to the 23 is Avogadro's constant, and we call that a mole. That just gave us a new conversion factor. The new conversion factor, I know it's hard to read, but it tells us 1 mole equals 6.02 times 10 raised to the 23rd molecules or atoms. So then, by definition, a mole is a quantity of atoms necessary to equal the element's atomic mass in grams. Again, definition, very important. There are a bunch of definitions throughout this chemquest. We will worry about the definitions when I come back. We are probably going to have a vocab quiz before the end of the unit quiz, just because of how important vocab is in this section. So then that actually gave us another conversion factor. So down here I have a new conversion factor. This conversion factor is 1 mole equals any atom's mass on the periodic table. So in this paragraph right here, it tells us that gold has a mass of 196.97 grams. To reach that mass, you would need 6.02 times 10 to the 23rd atoms of gold, which is also equal to 1 mole. The same thing is true for sodium. So if you looked at the mass of sodium on the periodic table, it's about 22.99. So to reach 22.99 grams, you would have to have 6.02 times 10 to the 23rd atoms, and then that would equal 1 mole. So when you are answering questions 6 through 10, remember that the mass of 1 mole is always the mass that's found on the periodic table, and if you have the amount of atoms of 1 mole, it's always 6.02 times 10 to the 23rd. That will be very helpful when you're answering questions 6 through 10. So next we come down to some information on molecular mass, also known as formula mass and molar mass. So this is where vocab is going to be very important. So in the first thing I highlighted, it reminds us that the atomic mass is the mass of an atom. The molecular mass is the mass of a molecule. Remember the difference between molecules and compounds. So remember, molecules are covalent and compounds are ionic. Oh, sorry, that's off to the side. So just remember the difference. So then when we get down here, because there is a difference between molecules and compounds, when it is an ionic bond, we call it a formula mass. So again, I know this is very blurry. This is very hard to see. We will worry about vocab when I come back. So one of the things I wrote down here to help us is if you are looking up the mass of an atom, so remember atoms are just your elements, so like carbon, oxygen, nitrogen, all you have to do is look up the mass on the periodic table. If you want to find the mass of a molecule or a compound, remember those are multiple atoms, so you would have to look up the mass on the periodic table and then just add. So remember, that's the difference between the masses of atoms and the masses of molecules and compounds. Up on the top, oops, sorry, it's hard to line it up with the webcam. All right, so right at the top, again, I have some stuff highlighted. It reminds us that 1 mole equals the mass in grams of an atom. It's the same thing for molecules and compounds. If you have 1 mole of a substance, it's always the mass that's found on the periodic table, whether you had to add it up in a molecule or compound or it's just an atom. So question 11. Question 11, we need to verify the mass of N2O5. So remember, we do this by using the masses on the periodic table. Again, it's hard to see, but I will explain it. So N2O5. So we have 2 nitrogens. So we take the subscript and we multiply it by 14. This was the mass that was found on the periodic table. Remember, it's a molecule, so we need to add. So now we do the same thing for oxygen. We take the 5 because the subscript for oxygen is a 5, and we multiply it by 16. Again, 16 is the mass we found on the periodic table. When we multiply and add, that does come out to 108 grams. So then now question 12, we need to think about how many molecules of N2O5 equal 108 grams. So remember, the mass that's found on the periodic table equals 1 mole. Is 108 grams the mass we find on the periodic table after we add up? Question 13. So question 13 is thinking about the difference between molecular mass versus formula mass. Try to remember the difference between ionic and covalent. Which one is associated with ionic bonds, which one is associated with covalent bonds. Questions 14 and 15 are adding up, are finding masses, molecular formula, and molar masses from the periodic table. So remember, you're going to have to multiply by the subscript. So find the masses on the periodic table for the atom, multiply the subscript, and then add, just like we did in number 11. Number 11 will show you how to do 14 and 15. Question 16, again, is just looking up the difference between molecular and molar mass, which you can find in the paragraph above us. All right, so now we are coming down to some mole conversions. Because of how important this is, I have to do something that I've been trying to avoid the entire time of making these videos. It is now time for me to be the star and actually appear in one of these videos. Alright, so I have to switch to the face cam because the face cam has a way better camera. So down here we are looking, oops, sorry. So right here we are looking at an example problem. So remember, you always need to convert to moles first. When you are converting, remember you can use these steps to help you. So when we are converting, the first thing to do is to start by writing down what we're starting with, 23.5 grams. We then need to set up our fractions. When you are converting moles, you're always going to need 2 fractions. You're always going to have to convert to moles first unless you are in moles. So the same rules apply. If we want our grams to cancel, we put our grams in the denominator, we put our moles on top. We use our conversion factors where any mole, 1 mole, equals the mass found on the periodic table. So we are finding for carbon, so I looked up the mass of carbon, it's 12. That's why 1 is over 12. Next, we would use the conversion factor because we need to convert to atoms. So use the conversion factor, 1 mole equals 6.02 times 10 to the 23rd atoms. Again, we plug these values in and then we solve using our calculator. The next example, question 5. So in the next example, question 5, we are figuring out molecules of carbon monoxide. So in this case, instead of having an atom, we have a molecule. Remember, carbon monoxide is CO, right up here. So we start off the same way. I start off by writing 50 grams. I set up my 2 fractions. I'm not in moles, so I need to have 2 fractions. So we would look right here. Grams needs to go on the bottom to cancel out. Remember, we need to use the mass found on the periodic table, so the mass of carbon monoxide. So that is what I did right here. I did 16 times 1 plus 12 times 1. 16 is the mass of carbon, 1 is the subscript of Sorry, I said that backwards. 16 is the mass of oxygen, 1 is the subscript for it, 12 is the mass for carbon, and 1 is the subscript for it. So 16 plus 12 is 28. That is why I use 28 right here. Again, the same conversion factor, whenever you have 1 mole of something, you're always going to have 6.02 times 10 to the 23rd molecules. So we just plug those values in, and then we solved. So remember, we're solving the same steps. It's really easy if you plug in where your units go to cancel, and then you plug in the values. Remember, when you're finding the masses are always found on the periodic tables. Whenever you're finding the molecules, 1 mole is always 6.02 times 10 to the 23rd molecules. So to help us with the next couple of problems, I have wrote some stuff in to help us. So right here is reminding us of our conversion factors. So remember, 1 mole of anything equals the mass that's found on the periodic table. Also remember that 1 mole of anything is always 6.02 times 10 to the 23rd atoms or molecules. So the first problem, I set it up for us. Remember, we started off by writing what we started with. I set up our two fractions. In this problem, I plugged the units in. Remember, if we want our grams to cancel, they go on the bottom. And then likewise, moles go on top. You have to convert to moles first. Then we can go from moles to atoms. Remember, moles would be on the bottom, atoms would be on top. Now it's up to you to plug in your conversion factors. If you plug in your conversion factors, right, you will get 3.82 times 10 to the 23rd atoms of gold. Next, for question 18, again, I set it up for you. Remember, we need two fractions. You're not in moles, so you need to convert to moles first. You're going to have to plug in your units this time. Plug in the correct conversion factors. Remember, when you are finding the mass of N2O5, that is going to have to be the molecular mass. So remember, when you're finding the mass from the periodic table, don't forget to add them up. Question 19. So question 19 is having us do it reverse. So instead of going from grams to molecules, now we're going to go from molecules to grams. It sets this up in 2 steps for you. So the first step, you're going to convert from molecules to moles. So again, I set this up for you. Or started to set it up for you. If you wanted our molecules to cancel, would they be in the numerator or the denominator? And then remember, we're converting to moles, so moles will be on the other spot. Remember, your conversion factor is right up here. Question 19b. So 19b, you're going to be converting from moles to grams. So you're going to take what you get in A, and this time you're going to have to set it up yourself. So write down what you're starting with, set up your fraction, and then convert. You are only going to need one fraction because you're already in moles. Question 20. So question 20 wants you to convert moles of copper to grams. So again, in this case, you are only going to have one fraction. You're only going to have one fraction because you are already in moles. Please, if you have any questions, make sure you circle it, write it down, and ask. I know that this video isn't ideal. Neither was the situation, so please just let me know if you need help. Write down your questions. We'll take care of it when I come back to class.